Look at this man running. He's training to run a marathon. He's covering a distance of 3 meters every second. So the distance he covers each second is constant at 3 meters, and he maintains the pace for a certain period of time. This is what we describe as uniform motion. So in case of uniform motion, if we know the constant distance covered for each time period along with the total time period of motion, we can calculate the total distance covered. What do I mean by this? If I said this man ran at a uniform speed of 3 meters per second for a minute, can you tell me how much distance he covered? A minute is 60 seconds. Each second the runner covered is 3 meters. So 60 times 3 is 180. Don't forget the unit. The answer will be 180 meters. Similarly, we can calculate how much distance we cover in 10 minutes, 20 minutes, or even an hour. That's because it's maintaining a constant speed. Distance traveled by an object per unit time is called speed. It's distance per unit time. So what will be the unit? Can you guess it? The SI unit of speed is meter per second. Quite often, you also see speed in centimeter per second, miles per hour, or kilometers per hour, but the standard unit remains meter per second. We observe this gentleman running at a constant speed of 3 meters per second. He is definitely a career professional, but in day-to-day life, it is very rare to see uniform motion, whether it is walking or running, riding a bicycle, or being in a car. We walk briskly for a while, then get tired, and our pace slows down. Most of the times, we are not even in control of the speed. There are external factors like traffic lights, busy crowded areas, and the likes. The bicycle ride is fast at times and slow at other times, depending on which area of the school you are in. Same goes for driving a car. Such cases are examples of non-uniform motion. The speed of the object is not constant. Hang on. Can we calculate speed from non-uniform motion? As the motion is not uniform, it will have different speed at different points in time. When it comes to non-uniform motion, we refer to the rate of motion in terms of average speed. Average speed. So how can we derive average speed? This boy leaves point A to reach point B, which is 60 meters away from A. As he has been walking at varied rates of motion, this will be non-uniform motion. It takes 60 seconds to reach point B, so he has covered 60 meters in 60 seconds. What is his speed? Can you tell? You would have probably guessed. We look at the total distance covered and we divide it by the time taken to arrive at this speed. So this ball has covered 60 meters in 60 seconds. So 60 divided by 60 equals 1 meter per second. That is average speed over this distance. It is as simple as this, but you have to be careful with the units used. You have to get into the habit right away and stick to standard units. If you understand it well right now, it will help you avoid silly mistakes in the future. If I had said this boy had covered 60 meters in 1 minute, you should not make the mistake of writing 60 divided by 1 equals 60 and say he is traveling at a speed of 60 meters per second. That's as fast as a bike. The best way normally is to convert to standard units. So let's convert 120 meters in a minute into meters per second. Meters is already in standard form, as the standard form of speed is meters per second. We need to convert this minute into second. 1 minute equals 60 seconds. This would mean distance covered was 120 meters in 60 seconds. So what was the distance covered in 1 second? Correct. 2 meters per second. So make sure to stick to standard units. Average speed is a good way to know when you reach certain destination in traffic. There will be times where you'll be driving fast, and at other times you'll be stuck. Hold on. At every instance, you are moving at some speed. It may be 0 meter per second for a stop, or 2 meters per second, or even 4 meters per second. Do you know what the speed at each instant is called? Yeah, it is called instantaneous speed.